Let us move on to the question 3 of exercise 7.1. Here's the diagram, a pretty easy one, and it is given that AD is perpendicular to AB. AD is perpendicular to AB. There I have marked the 90 degrees angle. It is also given that BC is perpendicular to AB in the question. So BC is perpendicular to AB. I have marked the 90 degrees. And AD is perpendicular to AB implies angle A is equal to 90 degrees. Angle B is also equal to 90 degrees, right? It is given in the question. And these two together mean that angle A is equal to angle B is equal to 90 degrees, right? It is also given in the question that AD is equal to BC. There I have marked it, right? And this mark is just nothing. Okay, so just ignore that. A slight mistake over here. Okay, we do now what is to be proved? We have to prove that CD, this proof is a little different. We have to prove that CD bisects AB, which means that this big line CD divides AB, CD divides AB in two equal parts. CD divides AB in two equal parts, and those two equal parts are namely AO and BO, right? So we have to prove that AO is equal to BO. We have to prove that AO is equal to BO. This is not given in the question, but this is what you derive. This is what you conclude by looking at the figure. It is just given in the question that CD bisects AB. Prove that CD bisects AB. CD bisects AB means that CD divides AB in two equal lengths, and since the two lengths are AO and BO, we have to prove that AO is equal to BO. So let us move on to the proof. Before proving AO is equal to BO, we have to prove that these two triangles, triangle OAD and triangle OBC, are congruent. Triangle OAD is congruent to triangle OBC, right? Only then you can prove that these two are equal by corresponding parts of congruent triangles. So let us see how we can prove the congruency of these two triangles. So let us begin. Okay, let us begin from here. Angle A is equal to angle B. Angle A is equal to angle B. It's already given, right? Or you can write given, or you can even write 90 degrees each. Okay, and then looking at the figure, it is also given that BC is equal to AD. So BC is equal to AD, and that is also given, right? And finally, you have proved that these two angles are equal. BC is equal to AD, and then what you have to prove is that this angle is equal to this angle. Angle C is equal to angle D. Let us see how you can prove it. First of all, we know that angle 1, this angle 1, is equal to angle 2 because they are vertically opposite angles. Lines and angles, recall that property. Vertically opposite angles are always equal. So we know that angle 1 is equal to angle 2. Okay. And we also know that angle 1 plus 90 degrees plus angle C, angle 1 plus 90 degrees plus angle C is equal to 180 degrees, right? And that is because angle sum property in triangle OBC. If you apply the angle sum property in triangle OBC, we get that angle 1 plus 90 degrees plus angle C is equal to 180 degrees. Similarly, if we apply the angle sum property in this triangle, angle OAD, then we get angle 2 plus 90 degrees plus angle D is equal to 180 degrees. And the reason is the same. Angle sum property in triangle OAD, that the reason will be the same. Okay, and this implies both of these are equal to 180 degrees, right? So you can just equate these two things. Angle 1 plus 90 degrees plus angle C is equal to, instead of writing 180 degrees, I write this equation because these two are equal. Angle 2 plus 90 degrees plus angle D. So 90 degrees and 90 degrees get cancelled out because they have the equal sign and they are on the opposite side of the equal sign, because they have the same signs and they are on the opposite sides of the equal to sign. Now what remains is that angle 1 plus angle C is equal to angle 2 plus angle D. But wait a minute, isn't angle 1 equal to angle 2 by the property of vertically opposite angles? Vertically opposite angles, right? So therefore these two angles are equal, so you can replace them by angle 1 only. Angle 1 plus angle C is equal to angle 2, but angle 2 is equal to angle 1, so instead of writing angle 2 I write angle 1 plus angle D. Again angle 1 and angle 1 get cancelled, therefore angle C is equal to angle D. So you have actually proved that angle C is equal to angle D, right? So you have angle B equal to angle A, BC is equal to AD, and angle C equal to angle D. Just pause the video for a while and just recall the properties of congruence of triangles. What all criterions we have learned? According to which criterion are these two triangles congruent? Just recall. I think you have already recalled. Yes, it is ASA congruence criterion, because this angle, this side and this angle are equal. ASA, the side is included between these two angles. So ASA, according to ASA rule, triangle OBC is congruent to triangle OAD. So you have proved it according to ASA rule. And therefore BO is equal to AO. BO is equal to AO. So you have proved that CD bisects AB, right? So BO is equal to AO, hence proved. Okay, so hence proved. This one was a little bit tricky question, but it was easy. It was actually easy to solve it.